Hi, my name is Jorge Ruiz. My group members are Masashi Yamaguchi, Kevin Toe, and Abraham Park, and this is our final project. Our extension, obviously, as you can see, we decided to go with the web application, and we're going to show you how it works right now. Go ahead and run. Okay, so it takes in the seed URL, and then the left search bar is the seed URL, and the right search bar is the query. And once we hit search, it basically sends it to the app.py, and then it runs crawler and the indexer. So as you can see, it's starting. Right now it's crawling. It's finished crawling, and now it's just showing all the output and creating the indexes. It's going through 50 pages, and we have a delay every 10 pages to be polite. And once it finishes, as you can see, we have all the scores here. The top score obviously being the top hit. And we're going to go ahead and show you all the time. So apply comes out 14 times on this page. And then on the last page, it should be a lower number. Apply only comes out once. So you can see the difference between the highest score and the lowest score. Now we're going to try a different URL. We're going to try Wikipedia, and our query is going to be football, and we're going to run through we're going to run through 50 pages, and okay, so it's starting now. Okay, so now it's finished crawling all the websites. Now it's again doing the indexing. We're going to cut this part because we already showed that it works. So we'll cut back to when the results are shown. Okay, and we're back. As you can see, we got 3 hits. So out of those 50 pages, only 3 of them had the word football in them. So we'll go ahead and look through this first one. And football comes out in this one 23 times. And on the lowest scoring one, it comes out twice. So we can see there's a big difference between a page about a football team and a page about not football. But yeah. Now, we're going to rerun it again, this time sorting it as a priority queue. The priority queue sorts by the last time it was updated. So we'll see the differences from there. It should take a little bit longer to run because, again, it is sorting everything. Okay, so it's finished crawling, and now it's just going to show all the output. And here we are. So it's going to come up with the same results, but um, the URLs were sorted based off of the time that they were last updated. Now we're going to try the same thing with 200 pages instead of only 50. And this one should take a little while to run. And we'll do the same query and seed URL. Okay, we're back. So as you can see, we got more hits this time. And here we're going to check the scores again. And we could see 23 times in the first one. And if we check the lowest scoring one, it should be a lot lower. And football comes out once. So as you can see, there's a big difference between all of the documents and their scores. But yeah, that concludes our functionality analysis. Okay, so now we're going to go through each part of our project. So we're going to start with the crawler. So the crawler takes in the seed URL, number of pages we want to crawl, and the deepest level we want to go to. So we start off by just adding the seed URL onto our queue. And while the current level is less than the deepest level we want to get to, we're going to get the text from each URL. We're going to double check. So then we're going to get all of the outgoing links, make sure that we're adhering to robots.txt. Then we're going to check for duplicate URLs. And then to be polite, we decided to add a delay after we crawl 10 pages, so that we're adding a 5-second delay after that. And then once we meet all those requirements, then we append that URL onto our queue. And then Wikipedia uses shortcuts to and removes like a bunch of the code that we it uses a shortcut, so we need to account for that. So that's why we have this Wikipedia stuff. But it does the same thing. It'll make sure it meets all these requirements and then add that to our queue. Okay, and then for this just basically goes into the robots.txt file, adds all of the rules onto a data frame, and then returns that data frame. Get body text does exactly what the name implies. It goes through it uses beautiful soup to get the text from the main part of the body, and and it returns it as a string. And this is how this sort list by name function takes in our list of URLs, and then we check when what the date of the last page it was updated, and we'll append the highest the most recent update to the front of the queue, and anything less than it'll just append to the end. If it doesn't have one, it'll just append in the order that we crawled. And then this is our indexer. This is our part 2. We put in the elastic pass and the elastic endpoint onto there, and then we start going through each of our links. So we actually upload every document individually instead of just a bulk upload. So we take we put the URL, text, and the timestamp that we updated it, and then every iteration for every link we upload every document onto Elasticsearch, and then the next part is we search through the query. This is where we give the query, and it returns all the hits, and that's it. Okay, so now we're going to be going over our web page. So we're going to start in the basically we're going to start in our index function. So we're going to get the seed URL from the input on the HTML file, and then we're also going from the search bar for the seed URL and also the search bar for the query. We're going to take those and we're going to pass them into the crawler, and we're going to run our crawler. Once the crawler finishes executing, we're going to it's going to return our indexes, and we're going to iterate through those, and it's going to build a string, and we're just going to simply return that string. Now our HTML file it's a pretty bare bones website. We just have the title. The input down here on line 19 and 20 is just getting this sets up those little text boxes and the search bar. And that's about it.